Good morning, everyone. I think everybody's here. Thank you very much for attending this meeting. We'll share my screen to present you the agenda for this meeting. So this meeting is intended to follow up on the various discussions we had in the past few weeks regarding how to strengthen the COGNIFOG trials. And for these, we had some discussions with technical partners in previous meetings, and we wanted to have a general overview of the COGNIFOG technology, including architecture, testing infrastructure, and then the quick start as well, in order to have a general presentation of how the COGNIFOG project has been building up, and give some information to the trial partners to improve how they deploy their trials, including the underused components of the COGNIFOG technology. And the broader objective is actually to highlight the key value added of COGNIFOG. What is new? What is novel? What is the COGNIFOG continuum? And how does cognition help to exploit the continuum to adapt to resource changes? And then look for ways to exploit those novel features, and how we can tweak our trials to exploit these novel or new features. And finally, some important question that was raised several times is validate these by revisiting our KPIs to ensure that they showcase these novel features. So the webinar will be divided into two parts, and I hope we will be able to cover all of it today, but if not, we will organize a follow-up session. So in the first part, we will have a presentation of the COGNIFOG architecture and components with three separate presentations, or four, which is an overview of the COGNIFOG architecture and the testing infrastructure, presentation of or short tutorial of the quick start, and then a presentation of underused components in the trials. In the second part, we will have a presentation by the trial partners of the deployment view, data flows, component plan to be exploited, etc. And then we'll turn to the KPI evaluation plans, and of course we'll have some Q&A if need be. So I would like to turn to the first agenda item, which is the COGNIFOG architecture. And for this, I discussed with Emna, which agreed to have a presentation of such architecture. So Emna, the floor is yours.
Thank you, Federico. So from my side, I will be actually using Deliverable 2.4 as a baseline for the presentation instead of slides, because it has it all. And it will be basically a reminder. I'm trying to share my screen, but okay. Sorry, but I have my computer not behaving well for some reason. Do you see my screen?
Yes, we do.
Yes. Okay. So I'm going. Do you see it or screen? Yeah, it will be better like this. Okay, so just a quick reminder of the architecture of COGNIFOG. Actually, it will be also a reminder for myself. I didn't see it since the submission of Deliverable 2.4. But in a nutshell, COGNIFOG is a platform / a toolbox where we have different components that the user can use according to its need, basically. So these different components will help the user automatize and prepare his workload during its life cycle from the modeling phase to the DevOps to the execution and runtime till the governance, where basically it's mainly the monitoring of the performance and the execution without having to develop everything from scratch. I would before going into the different components, and also because these components will be presented in the next session, the main thing that I wanted to highlight here is what COGNIFOG provides you with. So basically, the main component of COGNIFOG is this dashboard. For the user, I would say it's the main component from the user perspective, which will enable you to download and to upload your workload, the manifest of your workload, and deploy it on your infrastructure without having to worry where is it exactly deployed, what is the best setting for it to be deployed. Is my deployment energy efficient or computational efficient or anything? Where can I, how can I make sure that my workload is being deployed the correct way and is being performed the correct way? Everything is provided through this dashboard. Everything is automatized. And basically here you will have the main component that is managing all the other components, I would say, is the multi-cluster orchestrator developed by Thales, which will work always in tandem with the smart allocator of Siemens, and also the network slice manager of IoT-edge-cloud. And basically, whenever you create a new request with your workload, the mighty orchestrator with the smart allocator will deploy your workload the best way possible according obviously to the requirements that you put inside your manifest. For the dashboard, besides the execution, you have another layer, another page, which is responsible of monitoring, where basically different monitors agents that are deployed everywhere on your infrastructure will send their logs to a monitoring manager. This monitoring manager is connected to the dashboard and will give you the opportunity to display all the information that are collected from your infrastructure, and that will guide you through the next decision you would like to take regarding your workload. Another very important page that is included in the dashboard will enable you first to check how your workload would behave. And this is called the modeling page before its execution. So basically, when you upload your workload, you will there is a page that is connected to the different modeling tools of COGNIFOG that will give you an overview of how your workload will be behaving, how is it will be deployed on the infrastructure. This also will give you a first information about the overall operation of your workload, and here you can obviously decide probably to change some setting, to change some connection between different components. This modeling page, you will also be able to use it afterward, meaning after your workload is being deployed, because it will actually give you feedback on how is it working. And like this, you can, for instance, decide to change some configuration of your running workload, and to do so, you will need to stop your running workload and create a new request with the new configuration. For the DevOps tools, here it will include all the standard DevOps tools that all of us are using, but are provided in a more intuitive way and in such a way that is compatible with all the different tools that each one of us has been embedding in its internal pipeline. Then for the runtime, maybe going a little bit into the details of what are the services and tools that are available for your workload to interact with when it is being executed. I will go from the IoT level up to the cloud level. Because most of the workloads in the different trials uses this approach. So basically, for the IoT components, you will have the edge gateway, which this component will facilitate the interaction with the different type of components that are using different communication protocols. It will collect all the data and it will send it to the CANT-UI using some more standard format. Then with the CANT-U components, you will be able to aggregate all this data that is collected. You can also visualize it. You can do some filtering. Actually, the filtering starts with the edge gateway, if I'm not mistaken. But with the CANT-UI, basically, it will provide you with a seamless layer for data processing that doesn't really that make the source of this data that you collected completely transparent. And then this data is sent to the cloud level, or probably also to an edge level for which has more powerful computational power to do further processing, to do some visualization, some segmentation of data. And all of this is done according to a fog scheme from a computational point of view, meaning that it's not really important where each workload is being executed. It's more about what is the best the best configuration and the best scenario for that workload to be executed. Obviously, we have a lot of monitoring and telemetry that can be deployed on the things level, not necessarily on the edge, on the IoT devices themselves, because of some restriction coming from computational point of view or even from access point of view. We have also some modeling agents. Basically provided by the polygraph that will also help you get this accurate modeling of the behavior of your workload through the dashboard, that are pretty much deployed wherever it is possible. The network slice manager will also work in a completely transparent way for the user point of view, but will be working according to the requirements that are specified in the manifest. It will basically create a new network slice whenever it's required. For instance, this can be done for different type of data. This can be done for security requirement. For instance, we can make sure that this type of data is also is only dedicated to this slice because it has to be isolated. But all this is operated through the orchestrator. Then we have some security components. We have Arca Trusted Operating System, which will provide a trusted execution environment for your sensitive workload. So, for instance, if you specify in your manifest that your workload is sensitive or it is processing sensitive data, then the orchestrator with a smart allocator will decide that this workload will have to be deployed on one of the nodes that is deploying Arca Trusted OS to have this isolation. We also have another component that is being developed by eBOS, which is operating mainly on the things level and which will work on the detection of vulnerabilities and security breach coming from the IoT devices, from their drivers, and from the way they behave. I think I covered pretty much everything. I'm sorry, I didn't do it in layer approach. I thought that it would be easier from the user perspective to understand it. But obviously, if you have any questions, I can answer. And I think that's it for me.
Thank you, Emna. Let's now turn to Grigoris.
Yes, hi everyone. I have prepared a few slides to show you a little bit about the infrastructure that we have been setting up for deployment and testing, mainly drawing from the work package for deliverables and D4.2 mostly. Let me share my screen. Right. So this is an overview of the testing infrastructure that's in place. We have cloud-based environments that are hosted in the partner's cloud infrastructure. There is infrastructure from Intra, IoT-CAD, EBOS, CA, KenQ at the moment that is set up. There is a comprehensive CI/CD platform with open source tools. There is secure VPN access for all the authorized partners, and we have multiple environments that support development, staging, and testing. The key components and tools for the deployment and infrastructure is the management Kubernetes cluster that is hosted in Intra's cloud. This consists of a control plane with 3 master nodes, an application plane with 3 worker nodes, a load balancer which is a dedicated node for directing and distributing traffic. We'll also handle networking and storage using persistent volumes for data persistence. This is a picture, an image you can also find in D4.2, which is a high-level architecture of the development and integration environment with the CI/CD cluster on top. And the Kubernetes management Kubernetes cluster deployment I explained to you before with 3 master nodes, the 3 worker nodes, and the load balancer. This is, I guess, by now well-known image of the CI/CD stack we've been using. The CI/CD tools are open source and mostly known to you. We have Jenkins for automation and pipelines, Harbor as a registry for containers, GitHub for managing source code, Keycloak for identity management, SonarQube to check code quality, and the Kubernetes dashboard available to all partners for monitoring. We have also have an image of the deployment view for the testing activity. So on top, you can see the different cloud environments provided by the different partners. Intra with these components here deployed on our cloud infrastructure, IoT-CAD with our own services and components, KenQ as well, CA and EBOS and SciSec with our own cloud infrastructures. And of course, the edge layer, we also have deployment on infrastructure by the pilots, TMA, Thales, and LMS, with edge components being deployed there. We have, for all these components I showed you before, of course, you can also find in deliverable D4.2 the hardware specifications that we have collected and have been deployed for all the components. There is also a security and access control process with a multi-layer security approach and role-based access control for different environments, of course, managed by Keycloak. The methodology now for testing and integration, we have a phased integration approach with defined milestones and a very specific integration plan. We have two dedicated namespaces, COGNIFOG Dev and COGNIFOG Stack, automated deployment pipelines, as some of the tech owners know and have been using through Jenkins, continuous monitoring through the dashboard. And we have templates for testing both software units and integration tests. That's from my side. Of course, we're all welcome for questions and comments for the overall deployment. Thank you.
Thank you, Grigoris. We'll now turn to Thales, which will provide us with a short tutorial on the quick start.
Yes, hi, Federico, good morning. So let me share my screen. Do you hear me?
Yes.
Oh,
yes.
Okay, Okay, so for today, as highlighted in the email by Federico, so the presentation will be about the quick start, the COGNIFOG quick start tool that we are using or deployment, and also explaining a little bit the trial that we are doing here at Thales. So for the trial, it will be about collaborative mission in urban areas. So during a flood event or something similar, and we would like to organize the teams that are managing or rescuing the area. Here on the figure on the left, we are describing the whole so the overview about the use case that we are developing. Okay, just checking. Okay, we'll just choose the arrow. So we have on the edge, as we can see here, we have sensors and cameras that they are transferring data either to the cloud or the edge for better processing. And we expect to have different sensors sending data to the edge and the cloud. And we would like to use relevant subsystems from the tech providers in order to manage in a better way the data and also the infrastructure that we will be using. The idea is to deploy on demand, let's say, on the network edge, the applications that we will be using, for instance, AI-based detection apps for analyzing the video traffic that we are using. Also, we are expecting to manage a set of drones that they are moving in a specific area, and also processing the data coming from sensors to analyze if there is any risk of a flood event. And the idea, of course, is to control and to efficiently manage the edge sites using the cloud, because, of course, obviously, the cloud has a holistic view about the deployment at the edge, and the cloud can provision efficiently the applications depending on the latency that we are requiring or the resources that we need, etc. And on the cloud, we expect to have also data visualization to provide for the users a better understanding of the situation that we may have. So this is the trial that we are expecting. Data coming from sources, processing at the edge, and also another processing layer at the cloud level. For quick start, it is a setup meant to speed up the deployment of the Thales trial. So what we saw already here, we are trying to automate as much as possible the deployment of the scenario that we are working on for the trial. And the objective of the quick start is to deploy on a single machine the deployment while solving the integration issues. And then the idea is to port what we are doing on quick start. I mean, the configuration files that we have created using Ansible, the environment that we create using Vagrant, and port those deployment or configuration files to a real deployment using physical servers and physical sensors. And also we are expecting to use video flows created by an emulator called Gazebo that creates video flows coming from drones. And the idea, obviously, is to automate the deployment and speed up the tests, and also solving the issues that we may face. As I said already, we use Ansible for configuration, Vagrant for provisioning the machines that we need, and in particular, Quick Start will create, if you just follow the GitHub the repo that we created for Quick Start. Basically, it will create 3 virtual machines, one VM, which is the cloud that we can see here on the left, and we have a set of services. We deployed a set of services for control and data management. Then you will have also 2 other VMs that represents the cloud, the edge, and we specifically create 2 clusters, 2 Kubernetes clusters using K3s. Along with the integration with the components, either from COGNIFOG or other components that we need for our trial. For instance, we use an MQTT broker to get the data from the data simulator that we use. It is provided by CA, by the way. So we collect the data using the MQTT broker. Then we have a Prometheus monitor for the data for monitoring. Then we can also at the same time deploy some applications. For instance, the AI monitoring app that we have here on our trial. So here we have an AI monitoring application using YOLO, and it uses also Polygraph for monitoring. Polygraph, which is provided by CA, by the way. So we can create any application here on demand, and we are using, as I said, a set of services either from COGNIFOG environment or open source tools. Also, we are using Kentu Hub here on the edge. So automatically, when you deploy or when you use a Quick Start, you will have the MQTT broker, Prometheus, Kentu Hub, Kentu Eye on the cloud, and also, as I said, we can use a Polygraph for applications deployment. And just to highlight that tomorrow, actually, we will have another meeting with Alexander Bern from CEA, as he already done some work to extend Quick Start by using some data coming from the environment. So he integrated already this with an app that he is using to visualize this on the data on the cloud. So we will have a meeting about this. But then basically, just to say that the Quick Start is basically meant to deploy what we have on the trial. But I will just add that for other partners, if they would like to speed up the tests and the deployment, or if they have a similar scenario where they have data coming from the far edge, the edge, or the cloud, they can use Quick Start for the deployment, and it is relatively easy to extend because we are using Helm charts to deploy the applications. Back to the trial. For the time being, we are on a phase going from the single machine deployment using quick start to the physical deployment or the testbed that we will use for the trial. This said that we are porting Ansible and Vagrant configurations to a real scenario where we're using Proxmox. We are using Proxmox actually to manage the physical servers, and we are porting those configurations for the time being in order to use it with the physical sensors, and as I said already, with also the AI app that we will use for processing the video flows that are coming from emulated drones. For the trial, until now, we are using Kentu Hub, Kentu UI for data visualization, Kentu Hub for data management. Polygraph will be also used in order to deploy the monitoring app that uses YOLO. And we are expecting also to use the QS scheduler, the smart allocator, for application placement. They said that from the cloud side that has this general view about the deployment, we can decide where to deploy the application based on a set of constraints. So this is to check. We are still in this phase. We are checking if we can integrate the QS scheduler for our trial. So
I think it's a good way to jump to the next agenda item, which is actually to discuss the so-called underused components. And for this, we have Siemens and Atos who agreed to have a presentation about how they see these underused components in the trials. I leave it to Klim, I guess, or Alberto to take the floor and make a short presentation about that.
I don't know, I can start. I see Alberto is also here, but maybe actually what we just discussed, I think that two things that sort of confusing. One is, like Intra created the infrastructure for us to develop things, right? To store our code, to have continuous integration pipelines, to have some authorization possibility with Keycloak. But somehow they also sort of developed a cluster. So they created a cluster where they, allow us to test things out, which is maybe okay. And someone from the project requires this infrastructure. I don't know. But the COGNIFOG solution in itself is tailored to create, to roll out such infrastructure, and then to roll out over to the tools like Kubernetes to orchestrate this infrastructure. And then on top, you have components that do some, fancy logic to orchestrate this or in a smarter way. And basically, as I see it, for example, the quick start basically is something that represents the COGNIFOG, sort of this logic where we roll out the infrastructure and then the components that manage this infrastructure. I don't see how the cluster that comes from the Intra is actually useful in order to demonstrate what COGNIFOG does. It's just because, in order to show what COGNIFOG does, you need to start from scratch. You need just to have a bare metal hardware, more or less, and show, okay, this is how you roll out the necessary software on this bare metal hardware. That's one thing to clarify, basically, the discussion that we have before. I don't know if it helps or not, but that's what I wanted to add there. Coming to the underused components, maybe the easiest way to show it would be just to go through the current state in the GitHub inside the quick start and check out what we have there. I will basically share my screen. So you could see that we have here Ansible, that we have here the way how we deploy things after the infrastructure is more or less taken under our control, or the bare metal things are taken on our control. And then we have KubeEdge, is something like just a Kubernetes that would run and help us orchestrate this infrastructure. And then on top, we have different software components. And I think what Federica meant by underused components is something like your scheduler, or here is also smart orchestrator. There are also a slice manager functionality, which is sort of not, it's, I think, not clear how those components are more or less interact between each other and how they fit. So I would say in current state, for example, in the quick start, because I think this is the most advanced as we got so far, right, in integrating different components. I see that QS scheduler is there, and then we have even some sort of documentation, and I think Kilian was able at some point to install it and to use it in order to schedule the application within a cluster of the quick start. For example, what I tried to reproduce the steps that described in the documentation. They didn't work out for me so far. There are some errors, but I could also imagine that some things got outdated over time. Then we also discussed last week and this week about the smart orchestrator folder here, which is basically should contain more or less the configuration files to set up the orchestrator from Atos. We are talking here about two components, QS scheduler and smart orchestrator, which is the naming is a bit, I don't know, maybe misleading, or they sometimes used in a similar way, saying that QS scheduler is the smart orchestrator, then sometimes QS scheduler called the smart allocator, and this is, I think, confusing for a lot of people. So I would say, if we talk about QS scheduler, this is just an extension to the usual Kubernetes orchestrator. And we are talking now about one Kubernetes cluster. This extension helps Kubernetes to schedule the workloads or applications in an optimal way on the available infrastructure, more or less. So, because if you don't have a QS scheduler, for example, then the person, the administrator, have to make a decision. Okay, I'm placing this application on this node of the cluster because this node is more powerful than another one, and this application requires more CPU or more memory, and therefore it has to be placed, I don't know, in the cloud, for example. So this is what QS Scheduler does. It basically has this possibility to knowing what kind of infrastructure you have in place and knowing what your application require in order to run. It would be able to match the requirements and place applications in application workloads to the right nodes within your cluster. So this is what QS Scheduler does. And the smart orchestrator here, since it's coming from Atos side, it actually has to deal with a multi-cluster approach. So when we do have not one cluster, but multiple clusters, multiple Kubernetes clusters, then it basically sits on top of our setup and says, okay, I have this many applications to run, but I also have not one cluster, but many clusters. So I need to more or less schedule the job, and I need to decide on which cluster I'm going to schedule it. So it basically sends the job to a specific cluster, and then something happens on the cluster. The job has to be scheduled on that cluster. Either it's done more or less by a specific cluster scheduler, or it can be done also by a QS scheduler. This integration we haven't tested, so the intention is that somehow these two components work together, and that if this scheduling happens in the multi-cluster environment, then on a cluster, the QS scheduler takes care of scheduling the workload in a specific node. What we are missing here as well is, I think, in Quick Start we don't have anything about the slice manager. And slice manager is something coming now from IoT-edge-cloud. But to me, actually, I cannot. I think I'm not able to explain how this is going to work, and how the integration could be made there. I don't know if Alberto could explain it, but so far there were no integration attempts into the Quick Start, and of course this is also, I don't know, something that maybe we have to do, or maybe Juan from Atos, also from IoT-edge-cloud, is doing it. But we haven't seen it yet in the code, at least. That's a bit of overview of current state. I don't know if this was more or less clear, or if you need.
So just to conclude the webinar, because we are running behind schedule, I would like to thank you. I will organize a follow-up webinar in the next few weeks. Let's see when everybody is available to continue the discussion. And just to say thank you for those who have presented, make the presentations of the webinar. Thank you very much, and see you next time.
Thank you for the Please also make available the recording, because it is very helpful, I think, for almost everyone. So please make the recording available. That's my.
Of course, I will upload it in the share folder.
Great, thanks.
Thank you, everyone.
So thank you very much.
Bye.
Thank you.
Thanks.
Bye-bye.
Bye.
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 Thank you.
Bye-bye.
Bye.